Facing problems in life? You know how to swim? No? So come, let's try to learn that. Rohan knew that he can swim in a still water at a speed of 3 kilometers per hour. Now he wants to cross that river that is flowing at a speed of 2 kilometers per hour. And he wants to reach the point directly opposite to his starting point. Your question is, in which direction should Rohan try to swim? That is, you have to find out the angle that Rohan's body makes with the river flow. Given that the river is 500 meters wide, how much time will Rohan take to cross the river? So the situation that he is into is as shown here. First, I am writing the things that are given. Velocity of Rohan with respect to river. Rohan is a man and I'm writing the letter M for Rohan. So I know velocity of Rohan, that is velocity of man with respect to river. I have velocity of a river with respect to ground, and I know the width of the river. So these three things are known to us. Now the first question will be to choose a coordinate axis. We have to imagine the situation and we have to draw a rough diagram for the given situation. So first of all, I can choose my starting point to be this. So this is that very point where Rohan starts. This is that very point where Rohan starts. Okay, so this is the starting point. Now this can be chosen as the origin. Origin is 0. You know how to draw x and y axis. X will be the horizontal direction and y is the vertical direction. So I attach my coordinate axis here. So this is x and this is y. Okay, this is x direction, this is y direction, and Rohan is here. I know the width of the river is 500 meters. So the river is like this. This can be the river and the width of the river is given. This is 500 meters. This thing is clear. So I know the velocity of river with respect to ground. So I'll draw this velocity here. This is velocity of river with respect to ground, and this is the velocity of man with respect to river. So this can be this velocity of man with respect to river. Now the question says that Rohan, the man, has to cross the point that is directly opposite the starting point. So this will be this, that is the y-axis. This will be the y-axis. So this angle can be supposed to be theta, that is the velocity of man with respect to river is forming an angle theta with the y-axis. Okay. As I talked about कि different people have different नज़रियाज़, ठीक है? किसी भी situation को देखने का नज़रिया सबका अलग होता है. Likewise in physics, you have to solve the problem in one frame of reference. And when you select that frame of reference, the problem should be worked in that very frame of reference that you have chosen. For example, in the present case, I will choose the reference frame attached with ground as my reference. Like what the situation will appear if someone is standing on the ground and watching Rohan's struggle. What would be the situation as seen from his eyes? So the person who is standing on the ground, we are working in that frame, the frame of reference. Likewise, there can be other frames of reference. For example, a frame of reference may be attached to a mosquito that is sitting on Rohan's shoulder. For example, if the mosquito was given the responsibility to narrate what all has happened from his frame of reference, so then we have to work in the frame of reference of the mosquito, and the results in the two cases will differ. So for the time being, we people are standing on the ground and we are solving the problem when the frame of reference is attached to ground. So this is clear? Okay, so now if this is clear, so I want the resultant of this that is the velocity of man with respect to ground to be in the y direction. I want the resultant to be in the y direction. You know, velocity is a vector. They have direction, magnitude, and they add according to the triangle law of addition. So talking about the addition of vectors, how do we add them? Vectors are always added according to the triangle law or parallelogram law of addition. If A and B are the two vectors to be added, take the vector A, tail of B coincides with the head of A. Now the vector joining the tail of A with the head of B is the vector sum of A and B. The same rule may be stated in a slightly different way. We know a parallel translation of a vector does not bring about any change in it. Thus we have another law, that is parallelogram law of addition. Here we draw two vectors A and B with both the tails coinciding. Taking these two as the adjacent sides, we complete the parallelogram. The diagonal through the common tails then gives the sum of these two vectors. Velocity of something with respect to the other thing is equal to the velocity of the first thing with respect to some common frame of reference minus the velocity of the second thing with respect to that common frame of reference. ठीक है, ये होता है ये. So if this one is man and this two is river, so velocity of man with respect to river will be equal to velocity of man with respect to ground minus velocity of river with respect to ground. And this common frame of reference is the ground. Like I want to see this situation as observed from the ground. So my this equation reduces to this. Okay, and I'm interested in finding the velocity of man with respect to ground. These two velocities are given. So velocity of man with respect to ground will be velocity of man with respect to river plus velocity of river with respect to ground. If I talk of velocity of Rohan with respect to water, that will be equal to velocity of Rohan with respect to ground minus velocity of water with respect to ground. Since Rohan has to reach the point directly opposite to the starting point and Rohan himself is sitting on the origin, so you can suppose the direction of the velocity of Rohan with respect to water making an angle theta with the y-axis. So now I cannot take two things at a time. So I have to solve this. So this is a vector. And vectors, they have direction, magnitude, and they add according to the triangle law of addition. The next step is that you cannot take two things at a time. You have to simplify the things. Take the components of the velocities in the x and the y directions. Now focus on this equation and I have to take the components of this equation in x and y directions. I have to take the components of this equation in x and y direction. Now taking the components in x direction, is it visible here? Is it visible here? No? So taking the components of this equation in the x direction, I will be having, I know the value here is 2 and I know the value here is 3. Okay. Now taking the components of this equation in the x direction, components कैसे लेते हैं? See, in the x direction you have to check how many vectors are there in the x direction. How many vectors are there that are totally lying in the x direction or they have some component in that direction. Now you can see this vector, that is velocity of river with respect to ground. This is lying in the x direction. And this velocity of man with respect to ground is completely lying in the y direction. So iska component in the y direction is 0 and velocity of man with respect to ground is having 0 component in x direction. Okay. However, velocity of man with respect to river is having a component in the y direction as well as in the x direction. So how do we obtain these components? Simply drop a perpendicular from this vector on the respective axis jahan pe you want to calculate the component. So this will be resolved into two directions, this and this. This vector, that is velocity of man with respect to river, has a component in the x direction as well as in the y direction. Okay. Now the component in the y direction is VMR cos theta, and the component in the x direction is VMR sin theta. Now in the x direction, you have to take the components for this equation. Velocity of man with respect to ground is having 0 component in x direction, so this is 0, and VMR is this. VMR is having a component. Next thing, you have to check the direction as well. So this is the positive direction and this is the negative x direction. So this will be minus VMR sin theta, and velocity of river with respect to ground, that is 2, and this is the positive x direction. So this will be the first equation that you will be getting. Now you have the value of VMR, that is 3 kilometers per hour. So this will be 0 is equal to minus 3 sin theta plus 2, and you get the value of sin theta to be 2 by 3. So once sin theta is known, you can calculate cos theta. So sin theta is known, this direction is known, you can calculate cos theta. Cos theta will be cos squared theta plus sin squared theta is equal to 1. So what will be its value? Root 5 by 3. So sin theta is known, cos theta is known. Now you can calculate theta. So you know the angle that Rohan's body is making with the river flow. So from there you can calculate your theta, because sin theta is known, and theta will be sin inverse of this 2 by 3. Similarly, you have to take your components along the y-axis, and putting the values, you can finally find your velocity of Rohan with respect to ground. The next thing is to find the time that Rohan will take to cross this river. For that, you have to take the components of this equation in the y direction. Now I have sin theta and cos theta, so I solve the equation in the y direction. In the y direction, I have this component which is lying completely. So velocity of man with respect to ground, that is, and velocity of man with respect to river is having a component in the y direction which is VMR, that is 3 cos theta, and cos theta is root 5 by 3. Put the value of this vector here, and VRG, this is having this vector is having no component in the y direction, so this is 0, and you get velocity of man with respect to ground to be root 5 kilometers per hour. Now if this is clear, you have obtained the velocity of man with respect to ground. That was the ultimate aim, कि जो यहाँ खड़ा है उसके हिसाब से रोहन की velocity क्या है. The person who is standing on the ground, what is Rohan's velocity with respect to the ground, with respect to the reference frame attached to the ground. Now this distance, the displacement, that is the width of the river, is as seen from the ground, and this is 500 meters and this is 500 meters. So time, you know, time is displacement divided by the velocity in the direction in which you are calculating the displacement. So velocity in the y direction, 2.500, and the velocity in the y direction. So you have to write here the velocity in the y direction and velocity as seen from the frame attached to the ground, because this displacement is as seen from the ground. So velocity will be this, root 5. And since the units are kilometers per hour, this is also in kilometers, so the answer will be in hours. This is the time. This is the time that Rohan will take to cross the river. So this is the time that is required. So can you believe that you had to solve this much to find the answer? So that was all for today, and I hope you liked the video. If you do not forget to give it a big thumbs up, and I'll be back with my next video. Till that time, do not forget to take really good care of yourselves.